Hi everyone, my name is Victor Nwoke. In this video, I'll walk you through a real Terraform project where I built a production-ready, scalable web application infrastructure on Azure Virtual Machine scale set behind a standard load balancer, secure energy that exposes the app through the load balancer, NAT gateway for control outbound traffic, and Linux VMs Bootstrap with Cloud Init. Cloud Init is an automated first boot provision engine used by Azure, AWS, and most Linux cloud platforms to configure virtual machine at startup. I will use it to deploy a game that reads the Azure instance metadata. Everything is infrastructure as a code, version control, and ready to plug into CI/CD. Next, I will break down each Terraform file and the best practice behind them. Now, before deploying anything with Terraform, I'll first create a remote backend where Terraform will store its state file. This is my bash script. This script uses the Azure CLI to provision a resource group, a storage account, and a blob container specifically for Terraform state file. Now, as you can see, I have the variables that stores my resource group name, the random storage account name, and the container name as tf state. Now, I'm using the git bash in my terminal. So to run this file, I'll use the // then the file name, which is backend.sh. Hit enter. Now, setting up a remote backend is one of the most important best practice. It gives me state locking, versioning and recovery, secure storage in Azure. Now it's deploying. Now that my backend is ready, I can point the Terraform to the storage account inside the backend.tf. I'll go to my Azure portal, refresh the resource group. Now this is the resource group I created for the state file. I'll copy the storage account name, open my VS Code. Now inside my backend.tf, I'll change the storage account name here. I'll replace it with the new and control save. And now that the backend is created, let me walk you through each Terraform files, starting with the backend.tf to the virtual machine scale set. Here in the backend.tf, we configure the remote state using the Azure RM backend. Means Terraform state is stored in Azure storage accounts, which we created earlier instead of our local.tf file on my laptop. This enables team collaboration, state locking, and reliability in CI/CD. Using Azure storage as a remote backend for production or team environment is to avoid state corruption and to support locking. So a dedicated storage account or a container for states with a clear key naming convention like the dev.terraform.tf states makes it easy to separate environment and rollback if needed. Next, we move to the provider.tf. Here I define which Terraform core version and which Azure provider version this project expects. This stops surprise breaking changes when new releases comes out and keeps project consistent on our machine or CI pipeline. Next, we have the variables.tf. Here I declare all the knobs for the project. Here we have the common tags map to apply to all the resources. We have the tags for the environment, owner, and modules. We have the variables for the location to apply to all the resources. So the default location is West US2. So we have the resource group name, which we'll be creating. We have the virtual machine name, the virtual network name. We have the variables for the subnet name. So we have also the variable for the virtual machine scale sets. Then we have the path for the SSH public key. I've already created the public key here. I use the SSH keygen to create my SSH public key, which is stored here. Put the paths here. So separating variables from logic is a fundamental practice. Terraform practice is allowed us to reuse across environments, and it makes CI/CD pipeline much easier to parameterize. And here next we are going to see the locals.tf. Here is where I keep the compute values and reusable maps. So we have here I added a modified on tag with the current dates, which automatically timestamp the deployments. Here you can see the format. Now here I define the virtual machine size map based on the environment. For the dev, we are using this size. For the staging, we are using this size. And for the prod, we are using this size. So here we select the virtual machine size based on the environment, and the allowed ports is a map. You can see is inside the curly brackets. We have the HTTP port, HTTPS, and the SSH. Next, we are going to the rg.tf. I keep it in the separate file because the resource group is the root of my hierarchy and the natural place to start when reasoning about the environment. We have the vnet.tf. Here I define all the networking primitives. So here we generated the random pet name for the load balancer host name using the random pets. We created the virtual network and the subnets. Here we use the /16 virtual network with a dedicated subnet. Here we created the public IP address for the load balancer. We reference the local the public IP name. So here we have the load balancer with the front end IP configuration and the back end address pool. Here we reference the local load balancer name, and we have the back end pool. Now we also set up the load balancer rule for the front end IP address and the back end pool. Now we added the NAT rule to allow the SSH access to the backend instances. We also created the public IP for the NAT gateway. We also added the NAT gateway to enable outbound traffic from the backend instances as well. So we added the life cycle to create before destroy, which is true. So we have the NAT gateway association to the subnet and also the NAT gateway public IP associations. So next we have the nsg.tf. Here is all about the security at the subnet level. Here we created this network security group and attached from the tag from the local common tags. So we use a dynamic block to loop over the local.allow ports, the HTTP, HTTPS, and SSH to automatically generate allow rules with the unique priorities. So we added specific rules to allow the Azure load balancer to port 80, which is required so the load balancer can probe and forward traffic to the virtual machines. So finally, we associate the energy to the subnet. So every virtual machine in this case set is protected by the same consistent rule set. So next, we have the virtual machines case set, which define the virtual machine himself using the Azure virtual machine orchestrated virtual machines case sets. So here we reference the local virtual machine final name. We use the location for the resource group, and the instance is 3. For the platform for domain counts, we use 1. For the zone, we are calling on deploy in one zone, and we for the tag we use the variables for common tag. For the operating system profile, I'm going to explain what this means, the custom data. So we use the base64 encode and reference our file, which I will explain next, the user data.sh, which is a bash script. So for the Linux configuration, we configure the disable password authentication as true. So we use the variable for the admin username. For the public SSH, so we call the file where we store our public SSH key. So for the lifecycle, we ignore changes as instance so that virtual machines case set is not recreated when the number of instances is changing. We have the user data.sh, which is the cloud init style bootstrap script. Here we deploy the Terraform PHP game deployment script. We deploy it as soon as the virtual machines case set is starting. We use this script to bootstrap it. So we start by using this command so that the script fails fast on any error or undefined variables. Then we update and install the Apache, PHP, and JQ using this command. Then we allow the HTTP and HTTPS if the UFW exists. So we ignore if it's not installed. As well, we set the permission for the web routes and the permission for the users. So we using this command, we replace the default page, the default HTML to the PHP, which is very important for our game. So we deploy and pull the PHP Terraform game from the GitHub. For my GitHub, this is my GitHub repo. So using this command, I pull the game from the GitHub repo as index.php. Here I use this command to ensure the Apache prefers PHP instead of the index.html. So lastly, I enable and restart the PHP Apache. So this bash script prepares an Ubuntu Linux live server to run a simple PHP game, and display its Azure virtual machine metadata. Using a bootstrap script with virtual machine skill set is a standard way to get immutable, reproducible instances instead of logging in and configuring manually. So we're pulling the app from the GitHub at boot time, keeps the image generic and the configuration as code. Now next we have the outputs.tf. This exposes virtual machine set name so I can easily see it after Terraform apply or custom it from other modules or pipeline. I'm going to run Terraform init to initialize our files. So now we have successfully initialized the Terraform. So next we are going to run the Terraform apply or the Terraform plan using this Terraform plan. So I want to know what will be created. I'll use the grep saying will be created to see what resources will be created if I apply the Terraform apply. You can see all the resources that will be created. We have all our resources, the load balancer, the backend pool, the NATS virtual machine skill set, and so on. Now let's deploy using the Terraform apply or to approve. Now we have provisioned all the entire infrastructure end to end in Azure. We can see we applied completed, the apply is completed. Resources created added is 19. So this is the output of the virtual machine skill set using the unique name. Now let's move to our Azure portal. So we're going to refresh the resource group. Then we enter our resource group, which we created our resources. Now you can see all resources are in our new resource group. Now we're going to enter our load balancer public name. So here is the load balancer IP address, and here is the DNS name for our app. So we can use either of the two. So let's use this and enter in our browser. Now here is our game. So our app is live. You can see the virtual machine name here. We have the name and the unique name and ID. Refreshing this tab shows different virtual machine skill sets. We are going to be refreshing and watch as the virtual machine name changes. Here, refreshing shows different virtual machine instance serving the PHP app. That confirms that the virtual machine skill set and the load balancer are working. Each virtual machine also exposes its Azure instance metadata inside the app. You can see you can play the games. That brings us to the end of this walkthrough. In this project, I demonstrated how to deploy a production-grade scalable web application infrastructure on Azure using Terraform, integrating a virtual machine skill set, standard load balancer, secured network boundaries, and a fully automated cloud init provisioning. This approaches follows Azure and Terraform best practice for scalability, security, reliability, and infrastructure as a code governance. Thanks for watching. More cloud projects coming soon, and see you on the next one. Cheers.